Hello there. We start off with the second class of the chapter Binomial Theorem. And in this class, we are going to discuss the concept of general term and the concept of middle term. So, to begin with, general term. Now, what is the idea of general term? Now, as we all know, that binomial expansion, given it completely depends on the power to which you are trying to expand the binomial. Now, if the power gets huge, then it is not possible for us to write all the terms in that particular expansion. So in that case, what we do, we write a generic term. A generic term means a term having dummy indexes, where if we replace the value of the index by some integer, which is obviously between 0 to the highest it can go up to the power of the expansion, then we get all the different terms that we have in the expansion. So let us start off with the idea. Let us take a plus b whole to the power n, which is the most common binomial expansion that we have. And we have already done this in our previous class, that this is how the expansion looks like. Now, if we just follow this, if we just look at this, this is our first term. So let me mark this as A1, or rather, let me just mark it using T1. So that is the common way of denoting. This one is T2, this is T3, and so on it goes till the last one, which is Tn, right? Now, I shouldn't say this is actually Tn. I should be resisting the temptation of writing that as Tn. Anyway, so now if you see that, if you just look at the first term, it is nc0 a to the power n. In the second term, it is nc1 a to the power n minus 1 b. Then in the third term, it is nc2 a to the power n minus 2 b square. So if you just follow this, the term number and the all the numbers that are involved in the term itself, so this one, this one, this one, so all the term numbers and the numbers involved in the actual term, it's just one less. So therefore, if I want to write the general term just following this pattern, then what is the general term? Then the general term can be written something like this, which is basically T r plus 1. R plus 1 means that r is the dummy index that which we are making use of, and that can be written as ncr a to the power n minus r b to the power r. So here, if you see, if you just go on putting the value of r as anything, then you will see that you will get, obviously anything here is a very vague answer, but the value of r has to lie between 0 and n. If we put any value between 0 to n, we'll see that we get any, means that particular term which we are talking about or which we require. So now let us see some other general term. So 1 plus x whole to the power n, that is ncr x to the power r, so that is our general term for this one. Then if we have 1 minus x to the power n, then that becomes minus 1 to the power r, ncr x to the power r. Right? Now let us talk about middle term. Now middle term, by the idea, we can pretty well understand that we are talking about the term which is exactly in the middle of the expansion. Now why this is so important? Well, basically there's not much importance of having or talking about the middle term, but the idea is basically we are trying to understand that how many terms are there in the expansion. Now obviously from our very prerequisite idea of statistics, which we have already done previously from our junior classes, we are doing it. We already know that whenever we try to find the median value, if there are odd number of data, then there is exactly one middle value, and that is what we call as the median. But if there are two different middle values. That happens when the number of observations are even. Then we take the average, and whatever is the average, that we call as the median. So here we are going to have the same concept, but it is a little bit confusing. Why? Because if I have odd power, then the number of terms are going to become even, and if we have even power, then the number of terms are going to become odd. So that is the only confusing part in this, but otherwise it follows exactly the same idea. So if there are odd number of terms, then there will be one middle value, so that there will be one middle term. And if there are even number of terms, then there will be two middle terms. Fine. So first we have talked about if the power is even. If the power is even, then number of terms is odd, and so from there we get one middle term, and that middle term is given by t n by 2 plus 1. N is even, so n by 2 is just half of it plus 1. Similarly, if we have n as odd, then in that case n plus 1 will be even, so therefore there will be two middle terms, specifically t n plus 1 by 2 and t n plus 1 by 2 plus 1. So now let us take up few problems and let us solve. So the first one is write the general term in the expansion of x square minus xy whole to the power 12. So as we know, what is the general term? The general term formula, that is, if we just go by that, so it is tr, that is equals to ncr, tr plus 1, that is ncr a to the power n minus r times b to the power r. So here a stands for the first term, b stands for the second term. Now obviously if there is a sign involved, then I will consider it with sign, or we can just multiply with minus 1 to the power r. We can do it both ways. So therefore, following this particular formula, let us try writing this. So therefore, things are going to start something like this, and as you can see, I have done it this way. I have put that minus 1 to the power outside. There is no hard and fast rule that you have to do it like that, but it is good to do that because that's the convention. Not convention, I should say. It's like keeping that minus out helps you to calculate the minus sign along with its power. So that's basically, it's the convenience, not convention. So now what we have to do, we have to ensure that we club all the powers together and write everything in the reduced form. So x to the power 2 whole to the power 12 minus r becomes x to the power 24 minus 2r, and here I have x to the power r, so if you just multiply it becomes 24 minus r. Fine. So that's the general term of the expansion. Then find the third term in the expansion of 3x square minus 2 by x whole to the power 8. So 3x square minus 2 by x whole to the power 8. Here first I need to write the general term and then put the value of r accordingly to get the third term. So let us first write the general term. So the general term looks something like this. Now I think I need not explain why this is so. Now I need to find the third term. Now the third term will be basically 2 plus 1. Obviously, always remember it is tr plus 1. So whenever I am looking for the third term, it is basically written as 2 plus 1. So that 2 will be the one which I am trying to put in the formula. And then all I need to do is calculate, and after calculation, this is the answer. Fine. Next, number 3. Find the fourth term from the end in the expansion of x cubed by 2 minus 2 by x square whole to the power 9. Now, finding the fourth term from the end it can be done in lot of ways, but I'm going to do it the way which I find the best. And the best thing is to just reverse the order of the binomials. So if I reverse the order of the binomials, then what happens? The fourth term from the end becomes the fourth term from the beginning, because as I have reversed the order of the binomial. And so then we can follow the only formula which we know, so we don't have to learn a separate formula to find the fourth term from the end. So therefore, if I reverse the order, then it becomes something like this, that is minus 2 by x square plus x cube by 2 whole to the power 9, right? Now let me find the general term of this. So if I find the general term of this looks something like this. So 9cr minus 2 by x square whole to the power 9 minus r times x cube by 2 whole to the power r. Now in this case, you can see I have taken the minus along with the term itself. So I could have separately written minus 1 to the power r separately, but obviously here I am not much bothered with the general term, so I am not being very pedantic about this, the way I am writing it. Now let me put the value of r as 3, because I want the fourth term, so therefore r should be 3. So if I put r as 3 and calculate, after all the calculation that I do, then the fourth term from the end of the original expansion is 672 by x cube. Fine. Now let us move to number 4. Number 4. Find the term independent of x in the expansion of x minus 3 by x square whole to the power 18. Now let me explain what is term independent of x. Term independent of x means a term which does not contain x. So the power of x, here it is 0. So all I need to do is write the general term of this and then equate the power of x to be 0. Now obviously, before I can equate the power of x, I have to ensure I club all the power of x together right in the reduced form, and then I go on equating it with 0. So let's do it. So to begin with, this is the general term and this is the condensed form of the general term, means clubbing all the powers together. Now all I need to do is equate the power to 0. So that is 18 minus 3r equals to 0. And that gives me r equals to 6. So therefore, the seventh term, r plus 1, that is the seventh term in the expansion, is independent of x. And if we just do our calculation, then we'll see that in term independent of x is minus 3 to the power 6 times 18c6. Now obviously you can leave your answer there, or you can calculate and get it to, you can find the value of this, right? So now let us move to question number 5. Find the sum of the binomial coefficients of the expansion of 1 plus x whole to the power 50. Now this is a very good question and tricky question both. Now let us first understand what the question is asking. Now this is what the expansion looks like, right? To begin with, 1 plus x whole to the power 50. Now we all know the power is 50 means there will be 51 terms. So you can understand it's a huge expansion. Now it is asking to add up all the binomial coefficients. Now what do you mean by binomial coefficients? This one, only the number part in the expansion, leaving the variable, right? So this is called coefficient. So I have to add up all the coefficients. So like 50c0 plus 50c1 plus 50c2 plus so on up till 50c50, right? So that's exactly what the question is asking. Now obviously there's a formula for it. You can directly use the formula, or let us prove that formula through this. Now let me put x equals to 1 in this. So if I just put x equals to 1 in this, what happens? All x's will be replaced by 1. And what you are left with is basically the sum of all the coefficients. and on the left hand side you are left with 1 plus 1 to the power 50, and that is basically 2 to the power 50. So therefore this gives the answer that if I add up all the binomial coefficient of a particular expansion, or particularly this expansion 1 plus x whole to the power 50, the answer is going to be 2 to the power 50, and we can guess that 2 to the power 50 is quite a huge number, right? So that's your answer. Number 6. Find the middle term in the expansion of x by 3 plus 9y whole to the power 10. Now obviously first thing to look is the power, which is 10 even, so therefore number of terms, that is 10 plus 1, which is going to be odd. So therefore there is only one middle term, and what will be that middle term? It will be basically n by 2 plus 1, that's what it is, or rather 11 plus 1 by 2. You can do it all the possible way you can, and so therefore it is this. So just do your calculation and you will get it right. Now let us move to number 7. Find the coefficient of x to the power 15 in the expansion of x minus x squared whole to the power 10. Now this question is pretty much like finding the term independent of x, but here they are specifically mentioning that the power of x is 15. So all I need to do is find the general term, club all the power of x, and then equate the power to 15. Instead of equating it to 0 in the case of independent of x, here I will be equating it to 15. So basically this is your general term, clubbing all the power, this is what we get, and then equating it to 15. Equating this to 15, I get the value of r as 5. So therefore to find the coefficient, all I need to do is put the value of r as 5, do our calculation, it comes out to be minus 252x to the power 15. So that means the coefficient is basically minus 252. Fine. Now let us move to number 8, and which is the last problem. Now this problem is going to be a bit big one, but we have already done this kind of problem previously, so it won't be a problem understanding. In the chapter of permutation combination we have done this. So the question is, if the first 3 terms in the expansion of a positive integral power of a binomial are 729, 7290 and 30375, then find the binomial expansion. So nothing told about the binomial expansion, it is just told that it is a positive integral power of a binomial. So given this particular thing, positive integral power of a binomial, now that means what? That means that I can consider the binomial to be a plus b whole to the power n, where this n is positive. Obviously we are all dealing with positive integral powers, we are not dealing with any other kind of power. So therefore this is what this means, positive integral power of a binomial. So once this is understood, so let me consider the binomial to be a plus b whole to the power n. So what are the things that we need to find out? We need to find out the value of a, we need to find the value of b, and then we need to find the value of n, right? So that will give me the binomial. So now let me first find out what are the 3 terms. So the first term is a to the power n, obviously. The second term will be n into a to the power n minus 1. Then the third term will be nc2, that is n into n minus 1 by 2, a to the power n minus 2, b square, or b to the power 2, right? Now it is given that these are the terms 729, 7290 and 30375. So let us equate them. So these are the things given. So let me just, a to the power n is 729, this is 7290, and this is 30375. So now what I have done, I have taken ratios. So with the first term and ratio with the second term, then that gives me this particular relation. So I'll just keep that relation. Then I have done what? I have done another one, the similar one, where I have taken ratio between T3 and T2, and that gives me another relation. This is relation number 2. Now what we are going to do, we are going to do some replacement. And after doing that replacement, what kind of replacement we are doing? We are doing this, or dividing the first one by the second one, whatever. Now if I do this, I can see that A gets cancelled, B also gets cancelled, so I am left with all n. Now if I do our calculation, just a routine calculation, we get the value of n as 6, and once we know the value of n as 6, we can just put the values into the equation or into the relations that we have found out, do our calculation, and we get the value of A to be 3 and B to be 5. So therefore the expansion is basically 3 plus 5 whole to the power 6. Right, so that is our answer. So that's it. Thank you so much, and as always, if you have any doubt, please get it clarified. Thank you.